Hello and welcome to a training session on using StatWizard's Data Setup Wizard. My name is George Boomer. Join me while we explore the challenges in setting up data for discrete choice models and how you can use the Data Wizard to address them. During this time we'll cover the following topics. We'll discuss briefly what discrete choice models are and why they are valuable to marketers. Illustrate why data setup can be the most time-consuming and often most confusing phase of a discrete choice project. Share with you the idea behind the Data Wizard. Then, in an online session, show you how to use the Data Wizard. Let's talk a bit about discrete choice models. Why are discrete choice models becoming widespread? Because they can help weigh the importance of features, pricing, and other product attributes on consumer choice, and they can serve as engines for market simulators that can help project the success of new products in a competitive marketplace. What's the theory underlying discrete choice models? Reduced to essentials, it's that all transactions involve choice, and choice in turn consists of two components. A systematic component involving rational, observable comparison of product attributes, and an unobservable or random component consisting of an amalgam of things such as impulse buys, irrational or psychological elements, and so forth. Discrete choice techniques model the systematic component and assume the unobservable component follows a specific distribution. Why is modeling the systematic component important? The answer is that it can tell you what combination of features and pricing have the most appeal to potential customers. Discrete choice models are wonderful tools, but they can be difficult to create. Here's why. An internal study by McKinsey & Company revealed that about 65% of the time in a typical engagement was spent gathering and organizing client data. Data for discrete choice projects pose similar challenges. The reason for this is that all discrete choice estimation packages require data to be organized in complex ways. Sawtooth software requires CHO files. Latent Gold Choice requires 3 SPSS files. LIMDEP requires comma delimited but not CSV text files. And other packages have their own separate and distinct requirements. In fact, no two packages share the same requirements or use common standards. So even with a good relational database, such as Access, SQL, or Spss, data setup can take between 1 to 3 days. For most organizations, this represents a considerable, even excessive, expenditure of resources. We'll illustrate the problem using a simple shoe example. Our example includes 3 attributes: fashion, quality, and price. The first 2 have 2 levels, and the last has 5. For fashion, we have traditional and modern. For quality, standard and high. And for price, a range from $25 to $125. We arranged our 3 attributes according to an experimental design and organized them into 8 store visits, one of which you see here. We sampled, quote unquote, 400 hypothetical subjects and collected their responses into an Excel dataset. The dataset contained the 8 choices each respondent made, along with his or her gender and age. It's a modest dataset with 400 lines. Using our shoe example, let's see what data files look like for 3 popular discrete choice estimation programs. Sawtooth software uses CHO files that combine design elements and responses in a specific way. Each data item in each line has a special value, requiring some study to understand. The files are lengthy. This relatively simple one, based on only 3 attributes and 400 responses, goes on for 16,400 lines, making it impossible to assemble by hand. Latent Gold has a completely different data requirement. It reads 3 separate SPSS files. One contains responses, one the design, and one how the design is organized into store visits. LIMDEP requires data to be organized in what's called a stacked format, in which each line represents one alternative in one store, along with the descriptive information about the respondent. By its very nature, this format requires a lot of data. In this case, 12,803 lines. To make things worse, undocumented traps exist, such as length and width limits on the variable list. Now, years ago, when we originally encountered these problems, they seemed formidable. Hours of struggle induced us to develop the data wizard. After more than 20 years of consulting work, we noticed that not 90%, not 95%, but 100% of client datasets arrived either in Excel workbooks or in SPSS files, which can be easily converted to Excel. Data are almost always organized with responses in rows and questions in columns. It seemed clear that Excel was the only platform to use for developing data setup software. So we were getting somewhere. What other things did we want? We wanted to let the user start with data organized in the same format as it arrived. We wanted to help new users every step of the way, but not slow down experienced users. Microsoft's wizard format provided a good way to achieve this objective. At no point do we want to present users with blank, empty fields. Rather, we included best practices as defaults at all decision points. We wanted to produce datasets and control files that could be used immediately by all major estimation programs. We wanted to make processing as fast as possible, under the assumption that our users' time was valuable and scarce. We wanted tight integration with other StatWizard's modules, which we will cover in other training sessions, and we wanted to set the price, in this case $500, so that payback was immediate. Using our shoe example, let's show you how the data wizard works. We'll cover data setup for 3 estimation packages: Sawtooth Software's CBC HB, Latent Gold Choice, and LimDeps in Logit. Even though we have a data file in Excel, we're going to take a brief detour and show you how to convert data files from SPSS to Excel. So here we have SPSS. It's a version of SPSS called PASW. Let's go open our shoe data file. It's in Data Wizard Demo, and there it is. It's called shoedata.sav. So we'll open that. We have all of our variables listed here in the left column. There's ID, sex, age, and all of the choices that each respondent has made. Here you can see the first dozen records. Again, IDs in the left-hand column. There's sex, age, and again the 8 choices. Now, one nice thing about SPSS is that it has these value labels. The value labels are associated with numeric values for the variables. So in this case, 1 equals male, 2 equals female. And then for age, we have 3 age categories that you see here. Let's save this as an Excel file. It turns out to be very easy. Just simply click File, Save As, and then for Save As type, you pick the appropriate Excel category. In this case, we're going to pick Excel 2007. Click Variables if you want to select all the variables or just some of the variables to save. In this case, we want to save all the variables, so we'll just take the defaults, click Save, overwrite it if it happens to be there, and now we're done. We have an Excel file that's a copy of what you see here. At this point, we have our survey file, either from the survey house or from an SPSS file that we've converted. So let's go load that. It's under Documents, My Documents, Data Wizard Demo, and there it is, shoe data file. Here's our file. It contains IDs in the first column, sex, age, and then the choices made for each of the store visits in the remaining columns. The next step is to ensure that the wizard itself is loaded. So we click on the Excel Office button. In earlier versions of Excel, you do something a little bit different. Click on Excel Add-ins, Click down here on the button labeled Go, and then ensure that Data Setup Wizard is checked. Now we're ready to go. Click on the Add-ins tab, and you can see that Setup Discrete Choice Data is added as an additional menu command. So we can just click on that button. You see an authentication screen pop up. We are licensed, so all we need to do is click on the Continue button. And then you see the very first step of the Data Setup Facilitator. If you have left your cursor anywhere inside the data table, the Data Wizard will automatically pick the extent of the table, and that's exactly what it's done here. You can override that if you wish, but normally that's not necessary. So click on the next button. Now we're asked a question: whether the design spreadsheet was produced using the Design Wizard. That doesn't have to be the case. If you created the design using something else, that's fine. The Data Wizard can accommodate that. But in our case, let's just assume that we have used the Design Wizard, so we'll check this box. And then we'll move on to click the button that will add summary data to our spreadsheet. A dialog box pops up, asks for the location of our experimental design. So click OK. Here's our experimental design. We'll open it. And then we're guided for the next step. What you'll see here is that the Data Wizard has added 6 rows plus some additional information to our spreadsheet. It's taken the labels for each of our variables and constructed variable names from them. These variable names adhere to the formats that are required by various estimation packages. The wizards also counted the number of distinct values in each variable. So sex has 2, age has 3, choice 4. The wizards also guessed the data type for each one. So it knows that sex is binary because it contains 2 values, age is discrete, and it's identified all the remaining variables as choice variables. Now if we wish, we can change the labels for these variables, and let's just do that. Let's relabel this one gender instead of sex. And at this point, that's all we really need to do. We can run the Data Wizard again. Now here, notice that you're prompted for an SPSS file if one exists. If so, then the wizard will copy the variable labels from that SPSS file and include them in this Excel workbook. So let's just do that. Now, what happens at this point is that the Data Wizard scans all the variables to ensure that they conform to certain requirements. Here, it's noticed for the variable sex that it contains a range of variables from 1 to 2. And it asks you if you want to convert these to values of 0 and 1. Now, for some estimation packages, you don't have to do that. For others, it's desirable. For CBC-HB, we can leave them just as they are. And that's also true for all the other variables that we encounter. So we'll just simply click on No to All. Now it prompts us for the name of that SPSS file we said we have. So here it is. It's called shoedata.sav. Click on OK. And then the wizard tells us we have a successful validation. What's happened here is that the wizard has added 2 worksheets to our workbook. One of them is called variables, one of them is called labels. Variables contains variable names for all the values of discrete variables. And we have a second spreadsheet that in a sense has the same layout, except here what we're looking for are labels. Now because we have SPSS files, we just simply copied all the labels that you may recall from earlier, and then the wizard has gone ahead and constructed data variable names from those labels. So now we're ready to continue. We click on the Setup Discrete Choice Data button again. The new variables are checked, and we have a successful validation. At this point, we can select which estimation package we're going to use. If you click on the down arrow to the right of this box, you see all the various estimation packages that the Data Wizard can handle. Let's start by creating a Sawtooth Software CHO file. We will do this twice, once using experimental designs from the Design Wizard and once using a more generic approach. We start with the Design Wizard. Before we proceed any further, let's save this file in a form that we can use again, because we're going to go back and create a number of different data setups. So let's save this as shoe data ready for processing. There we go. Alright, let's rerun our Data Wizard, and this time we'll make a selection for Sawtooth Software. So let's click on the Create Files button, and you can see that it's quickly building an export sheet that has common formats that will be used later, and now it's processing each ID. You see that this is really a Windows issue, that Windows has stopped and it claims it's not responding, but actually the processing is taking place in the background. So at the end of this 20 seconds that you see here, you should see the finished product. So bear with me and let's wait until the processing finishes. Alright, there we go. We get a message that describes exactly what has happened. You can see that the wizard has created a CHO file along with an ATT, which is an attributes list, and an ASC file, and it tells you exactly what they are. The ASC contains a common delimited set of demographic data. The CHO file is something that we've discussed before, and the ATT file lists attributes and levels. So all we have to do is click OK and finish. And now let's go and just check out our CHO file. Find our CHO file. So it's exactly where all the other files are. So here we go. Go to My Documents, Data Wizard Demo, and there you see the ASC, ATT, and CHO files. So let's open the CHO file. We'll send it to something called TextPad, which is just a reader. Alright, let's resize the window a little bit. There we go. This is our CHO file. As you can see, it contains 16,400 lines. So that's all the time that it takes to create the CHO file. Let's do the same thing by looking at the other files. Here's your AT&T file. We'll send that to TextPad as well. And there's your ATT file. There are your attributes, there are your levels. So that's all ready to go. And then finally we've got the ASC file. And there it is. So that's all the trouble it takes to build a CHO file. Now, you don't have to have a Stat Wizard's Design Wizard in order to be able to do this. If you do not happen to have the Design Wizard, then what happens is the wizard actually builds a design file for you and walks you through the process. We actually did that in conjunction with some good folks at Bain & Company who had done this internally, and we've now taken that over. So that's all that it takes to build a CHO file. Next we'll create a similar CHO file, except this time we will use a design from Sawtooth Software. For this demonstration, we're going to use a data file and a design file that Sawtooth Software might create. So let's load those files. The first one is shoe responses from Sawtooth Software. You'll notice that the only difference between this file and the files we've been using in other examples is that the ID is labeled RESP ID. And the reason for that is that the Data Wizard uses this to identify the file as a Sawtooth Software file. Let's also just take a look at the design file. Even though we don't have to load it, we'll do that anyway. Here's what the design looks like. And you can see the column headings are task, concept, and then we've got ATT columns for fashion, quality, and price. Okay, so let's go back to our data file and run the data wizard. We get the authentication screen. We go past the next screen. Now the difference here is that instead of checking this box saying that the design spreadsheet was produced using the design wizard, we go right to the button in panel B. So let's click on that, and you see that the data wizard, recognizing this is a Sawtooth software file, asks us if that's indeed the case, and we click on yes. And then it asks whether or not the design file was created by Sawtooth software or by Stat Wizards, in this case Sawtooth software. And we happen to have an ATT file, so we check this box. Neither one of these two files are necessary, but they're helpful if they exist. So we click OK to close this dialog box. We're now asked for the workbook that contains the Sawtooth software design file. And we'll click on that. Now notice that we already have it loaded, but the wizard takes care of that. It just simply says, okay, the one that's loaded is the one we're going to use. Then it asks us for the ATT file. So we go and get that and open it. And now it tells us that we have a design file that we need to replace, so let's say yes. What this design file is something that the data wizard creates. It's a Stat Wizards-like design file that the data wizard creates from all the information that's collected so far, and then it uses that to produce the data sets. Next, the data wizard tells us that it's going to replace RESP ID with ID, so we say yes, and then the data wizard gives us a list of things to do. I'm just going to click to close this now. You can copy all this to Word so you can go over it line by line, but we just won't do that right now. So we close the box, and what you see here is that the data wizard has added a new worksheet to our workbook. The worksheet is called Settings. They're really settings for Sawtooth software. So here we have, for example, the none variable. By the way, all these boxes are preloaded with the best answers to these questions based upon all the information the data wizard's collected so far. So here you can choose a dual response none, an absence of none, or yes, there is a none. And then in this next box in cell C5, you can choose that it's either a first choice only model, a max diff model, or the first n choices. Now these settings are just fine for us, so we go back and we take a look at the settings in the first worksheet. Here what we're going to do is to ignore sex and age, and this is true not just for Sawtooth software problems, but also for any data sets that the data wizard processes. You can always click on a data type and change it to ignore, in which case that variable will be ignored for the remainder of the data setup. So we've ignored these two. Let's go run the data wizard again. We'll ask to validate the data sheet. Got a successful validation. And now all we have to do is to go to panel A, use the drop-down box, select Sawtooth software, and then click on the Create Buttons file. And you see that things are processing very quickly. We only have a few seconds left. Again, this is an Excel and Windows problem. The dialog box says that this data setup facilitator is not responding. That's actually not true. It is responding. You'll see that in the next 20 seconds or so this will complete. There we go. And here we have a dialog box labeled Successful Completion. It tells you exactly what it has done. You can always copy this to Word, just as you can with many of these other complicated information boxes. Basically what's happened is that we've got a new CHO file, an ATT file, and an ASC file that were created for this problem. So all we have to do is click on OK, click Finish, and we're done. So let's go run CBCHB. Here it comes. This is the latest version. So we're going to browse for the CHO file we just created. There it is right there, datawizard.cho. We'll open that file. Click on Continue. Click on Estimate Parameters Now. Continue with the estimation. And off we go. We'll go ahead and let this complete, and what we might do is just pause a little bit so that we don't take up a lot of your time, and we'll just resume once the iterations are complete. The estimation is now complete, so we can click here to close it. You see just how fast you can put together a data estimation file for CBC HB. So we'll close all this. The new versions of CBC HB allow you to enter CSV files, but our experience is that using the data wizard is still much faster. So that's the example. We'll proceed to what's next. Now let's go back to our template file, and using our same shoe example, set up data for a latent goal choice. For latent goal choice, we use exactly the same data wizard setup file. So all we have to do is go and click Set up Discrete Choice Data. This time we will select latent goal choice from the drop-down list and click Create Files. And you can see that things are starting to process very quickly. We're building the datasheet with responses, we're creating all the SPSS files, and that's all the time it takes. So we've created all three SPSS files. In addition, we've created a template for running latent goal choice. So let's just take a look at these. First, let's take a look at the files we've just created. There's a response file. Let's just reposition it a little bit. Here is the file with alternatives. And then here is the set file, which tells latent goal choice how to organize the design and match it up with the store visits. All right. So you don't have to worry about any of that formatting at all. Okay, now let's take a look at latent goal choice itself. Let's open latent goal choice. There it is. We'll navigate to the template that the design and data wizard just created. There it is. We'll open that. Now let's double click on it to check it out. What you'll see is that the dependent variable, case ID, sets, all that has been set up for you. We've got covariates that at this point are included. Over in the attributes section, we've got all of our attributes, again, all set up properly. All the files are entered correctly. So literally all we have to do is click on estimate and watch latent goal choice process, and then click on response here, and we've got ourselves, in this short amount of time, a good model. So in this case we're looking for the BIC that's at its minimum, and we see that it is here for the 3-class choice model. So here's our model. So that's all the time it takes to put together a latent choice model. In our final demonstration, let's set up the shoe dataset for LIMDEP's nLogit, which supports nested logit and mixed logit modeling. Datasets for LIMDEP's nLogit are easy to set up. All you do is press the Discrete Choice Data button, select LIMDEP, either text file or Excel input file from the drop-down menu. In this case we'll pick text input file, and click on the Create Files button. And you can see that the data wizard has begun to process. Now it's going to take about a minute or so, so we'll pause and resume once processing is finished. We're finished now. Once that happens, you'll see a dialog box that's labeled Successful Completion, and then a number of instructions appear as well. You can save these instructions here and in many other dialog boxes by clicking on the Copy to Word button. Let's do that now. Alright, you'll see that there's some processing that's taking place, and now we're notified that a Word document is set up. We'll show you in a moment why that's going to be important. Alright, let's click Finish. And now let's run InLogit. Well, here's InLogit. The first thing you have to do is to set up the project so that it has enough memory to be able to execute your estimation. The Data Wizard has done a few things to make this a little easier. For one, it's placed the required number of cells in the clipboard, so all you have to do is select Paste and the right number of cells appear here. Another thing that is recommended to do is to put the correct number of rows here. Now there are a couple of ways we could get that. One is to load that Word file that we just created. Why don't we do that now? You'll find that that Word file appears in the recent items list from your Windows Start button. It's labeled Last Message from Data Setup Facilitator .x. And there it is. So let's scroll down and find the number of rows. There it is. It needs to be 12,800. Okay, so we can copy that and paste it in the right box, or type it in this case. Alright, so now we have the project settings set up just so we can run our particular estimation program. So we click on Run File, and you load a control file that the Data Wizard has set up for you that's called 01 readtext.lim. You run this, and you see from down here in the right hand corner that LimDep is processing this data file. Now you recall it's got 12,800 observations in this file, so it takes a little while to run. So we need to be a little patient, and again we'll wait until processing is finished. When processing completes, you'll see that the lower right hand corner contains the word idle. So our data set's been loaded. Now we can close the output window and open one of the templates that the Data Wizard has created. Let's open the nested logit template. What you see here is a control file that the Data Wizard created will allow us to estimate an initial model. This saves quite a bit of time because you don't have to pour through the manual trying to find out how to set up a nested logit problem. In fact, we can run this routine right from here. Let's do that. Let's select all the text and then click Go. And there you see the project execute, and it's all done. From the beginning, where we have nothing but a Data Wizard Excel spreadsheet, we've gone to estimating a nested logit model in just that short amount of time. So let's close InLogit. We won't save anything, and now we are returned to our original spreadsheet. Note that there's also a random parameters logit template that's available for your use. In summary, preparing data for estimation is always the most time-consuming part of any discrete choice project. The Data Wizard can save you time and therefore money in two ways. It automates the generation of data files, and it creates control files that can serve as starting points for estimating discrete choice models. It also integrates designs created by StatWizard's Design Wizard, if that's what you used, but lets you use designs from other sources as well. Finally, it facilitates creating simulators using StatWizard's Simulator Wizard, which we'll cover in later tutorials. That's the presentation for today. Here are some additional resources that might interest you if you would like more information about this topic. Please feel free to email me at any time. Thank you very much.